So hey guys, welcome back to my channel. Hope you are doing extremely well. This is your very own mascot at this side, and today I am here to show you the another POTD, which is longest repeating and non-overlapping substring. Now, for this question, I will have to demand your utter focus and just listen to me very carefully in the question in the full video, right? Because this question is a hard type problem, and believe me, it is really a hard type problem if you are not understanding it correctly. Okay, so let's move to the question. The question says that you have been given a string. Let's say the string is s, and you have to find the longest repeating and non-overlapping substring. Okay. For example, you can see s is a substring here. S is a substring here. You can see s is equals to this s plus these both s are like they are not overlapping. Like s is occurring from this index to only this index, and s is occurring from this index to only this index, right? They're not in the no overlapping area, right? If I consider ks, again correct. Similarly for eks, similarly for double eks, similarly for double eks, that is geeks, right? And you can see that geeks is the longest substring which is occurring twice, longest substring occurring at least twice, at least twice, right? Occurring at least twice, and just that. So my geeks will be my answer in this case, right? So I think that you are clear with the input and output of the problem. Now you just have to tell me how to solve it. That is very easy, right? That is the main thing. Approach. So as usual, we will discussing the brute force approach, and then we will move to the optimized one. So brute force approach. What can be a brute force approach? So suppose I have my string as geeks for geeks, right? The brute force approach says do what the question says. Do what the question says. The question says substring. Okay, I'll say form all the substrings. Like this is index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? All right, I will say go from 0 equals I equals to 0 till 11, that is n minus 1. Inside it, a nested loop. I j equals to 0 to n minus yeah, I, right? So first substring will be this, another will be this, another will be this, right? And so on and so forth. Let us consider the second substring, right? Like let us consider second substring for better optimal answers. So I have got gee in my answers, right? Ge in my first substring. For example, I is here, my j is here, and my substring is gee, right? We know that ge also exists here. So how can we reach here? How can we reach at this part from this part? What I can do is I'll say my s1 equals to, let's say this string is s dot sub str, that is take the substring out from starting from I, and what is the length? The length will be j minus I plus 1, right? Because j is 2, I is 0, correct? And the length is 3, so that is 2 minus 0 plus 1, right? I got my s1 as this. Now I will say start from this index, that is j plus 1, that is for int k equals to j plus 1, k going up till, let's say, what is this part, right? And then check if s dot sub str k j minus I plus 1 equals to s1, right? This is the condition, right? If I find a substring in this portion that is equals to this, I got my one of my potential answers, correct? I got one of my potential answers and store the maximum. Like my maximum is up till now is an empty string. And if this happens, and if j minus I plus 1 is greater than the length of maximum, then update your maximum. Then maximum is equals to s1, right? This will be my loop. Now, what is the time complexity? The time complexity to solve this problem is also, if you have seen my Rabin Carp video previously on the previous day, then you can do this step in O of n time, right? Because this is just pattern finding in a text is starting from here to here, right? So you can implement my Rabin Karp algorithm O of n time. This is running at O of n time. This is running O of n time. That is why the complexity is O of n cube. Are we using any extra space? No. So our space complexity is O of 1, right? Now the interviewer asks you, can you optimize it in any way? So you will say, yes, sir, I can optimize it, but I will have to use dynamic programming. The interviewer says, go on. How would you use that? Okay. So you will move to the optimized approach. Oh, sorry. Optimized approach. You will say, sir, create a table. Create a table. Create table like G E E K S for geeks. Suppose this is my column. This is my subsequent columns, and similarly G E E K S F O. Let me take the screen down a little bit. Yeah, G E E. Suppose K and S are here, right? Now what I will do is I will fill this DP table. This is my DP table. I'm using a memo tabulation method. What I will doing is, suppose these are my indexes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Correct? Alright. I'll say that suppose I'm standing at dp of I comma j. Row is I, column is j. Correct? Now I will say if S of I is equals to S of j. If I'm standing E and let's say this E, right? I'll say that these two E's are matching. These two E's are matching. Correct. If these two E's are matching, they're contributing one to the answer plus the value on the diagonal. That is for this G and this E. Am I right? Am I right? Right. So if my Si equals to Sj, then my dp of Si, so dp of ij will become 1 plus dp of I minus 1 j minus 1, right? And if it is not true, else dp of ij will remain 0, right? So let us fill out the table. Let me create a new one for you. So now when considering the substrings, like you're considering substrings starting ending at I, mark my words, ending at I and ending at j, ending at I and ending at j, right? So ending at I and ending at j, consider it like something else. Like my I is at zero, my I is at zero. So can my j, like my I is at zero, and this is my substring. Can my substring from j lie in this region? No, that will be overlapping, right? So what I will do is I will start from here. N. Are they matching? Yes, sir, they are matching. So what is this? This is 0 already. This will be 1. Am I correct here? Am I correct here? No, I'm not correct here. Why? Because this N and this N are matching. This N and this N are matching. How are they matching? Because they are overlapping. They are overlapping. So I cannot consider them as part of them. So N and N, it will be 0. E and D, they will be 0. T and T, they will be 0. So all diagonal elements will be 0. Okay, the diagonal elements are 0. To avoid overlapping, for your justification, to avoid overlapping, we will consider them as 0. Move here. Is N equals to E? No. It will remain 0. N equals to T? No. A no, G no, E no, T no, and A no. Right. Moving to E. Is it equal? No. Equal? No. Equal? No. E and E are equal. E and E are equal. So it can be a potential. So E and E are equal. So my answer was to add the diagonal element and to increment the diagonal element and fill it here. So it will be 1 plus 0, that is 1. T and equal? No. 0. No. Moving to T. Equal? No. Equal? No. Equal? No. T and T again. So 1 plus 1. 2. Correct. T and A? No. Moving to A. 0, 0, 0. 2 plus 1, 3. Right? Because A and A are matching. Moving to G. 0, 0, 0. E. 0, 0. T. 0. A is already a 0. Right? Now, many of you will ask, what about this part? What about this part? I'll say a very good question. What about this part? This part is of no use to you. You fill it with anything you want because this part is not used to you. Why? Because we will be considering substrings ending at I, ending at J, right? So if my I is here, right? My string, my this is my string. If my I is here, right, and my J is here, can my J ever be this way? Can my J can be ever less than I? No. Why? Because to avoid overlapping. So by j always be j will be always I plus 1 or further, right? So for that reason we are taking only this matrix, and we are I plus 1, that is the diagonal elements are also 0, right? Our first doubt is clear. Our second doubt remains as, suppose instead of this string, like the string would have been something like this. The string is this, right? So if you check it thoroughly, you will see that AABA is your potential answer. You can also use the dynamic programming table like just taught. AABA, AABA, right? So my answer should be AABA. But if you observe carefully, AABA is also occurring here. But this AABA is either overlapping with this one or this one, right? So we cannot use that. So how would we discard that? How would we discard this overlapping substring? Because you saw that we discarded these elements because of the overlapping, right? Right? We discarded them because of the overlapping. So what can we do now? So I'll say, what is the distance between two indexes? Like I'm standing at this A and I'm standing at this A, right? This is they are giving me a length of 3. Am I correct? So if they are giving me a length of 3, how can I discard it if this it is an overlapping? So you can see my J is currently 7, my I is 3, correct? So my distance between J and my I is somewhere here at index 3, my J is somewhere here, index 4. So what is the elements present here? 4, 5, 6. Three elements are present in between. So my substring ending at J can go maximum up till there, right? And I can go further where it wants to go. I don't care about I right now. So I can have a maximum length of J minus I, that is 7 minus 3, maximum length of J minus I. And if this turns out to be greater than, oh, sorry, this turns out to be greater than J minus I, that is dp of ij turns out to be greater, in that case make it 0, because in that case it will be an overlapping subcase and we don't want that, right? So this is my approach for you guys. Hope you liked it. Considering the time complexity, so we are traversing the table once, O of n square, no doubt. Also, we have created a space of O of n square only to store the TPA values. So it will be O of n square space complexity, O of n square time complexity. Hope you liked the exam explanation. If you liked it, please don't hesitate to subscribe to my channel and hit the like button. Alright, so let's move to the code, because I know many of you have been waiting for the code from very long. I hope you have understood the, what do we say, the approach, right? So let's see. So my int, let me name it as dp, declare the size of n plus 1, n plus 1, n plus 1, right? Now I will set all the values of dp as 0. So I can just do a vector, right? So vector int dp of size n plus 1, vector of int n plus 1, 0, right? Now my answer length, that is considered as res length, is equals to 0 right now, right? Now my int I is equals to 0. Int I just declare int I, and my index equals to 0 right now. Index is marking the index of the string, that will be my answer. And res length is calculating the maximum length up till now, which we have calculated. Now for int I going from 1 and going up till n I plus plus, right? Similarly for int j going from I plus 1 to j less than equals to n j plus plus, right? So my j is always starting from I plus 1, right? Now if, what was the condition, if j minus I is greater than dp of ij, right? And my si minus 1. Why minus 1? Because we are starting from 1. We are using one base indexing to fill the dp table, so I'm using it as minus 1. Si equals to s of j minus 1. In that case, what do we have to do? Oh sorry, I mentioned it here by mistake. Control x and control v, right? So what do we have to do? dp of ij, dp of ij, or also here I minus 1 j minus 1, sorry for my mistake guys, right? dp of ij will become equals to 1 plus dp of I minus 1 j minus 1, right? Am I right? Right. Also after that, if this happens, sorry, now if my dp of ij has exceeded my already maximum value, that is res length, what do you have to do in that case? You have to update our res length. So my res length will be equals to dp of ij, right? And what is my index? My index will be maximum of I comma index, right? After that, if this condition is not true, if this condition is not true, then uh, this condition, by this condition I mean this condition will come after this, right? Because we have updated and then we will check, right? And if this condition is not true, by this condition I mean this condition is not true, then fill the dpij with 0 only. You cannot do anything about that. So my dpij will remain 0, right? Now after the dp table has been filled, I have got my res length with me, I've got my index with me. So what I will do is, now if my res length is greater than 0, that means I have my answer with me in my hands. So what I will do is, for I int I, sorry, I only I have declared index minus res length. Why minus? Because index was marking the place where the string was ending. I plus 1, I less than equals to index I plus plus. What are we doing here? We are doing string result equals to, let us make it an empty string first, and we have to add the characters. Res plus equals to s of I minus 1, right? Now after this, if my res remains empty, in that case I have to return minus 1, res equals to minus 1, and then return your result. Hope it will work. Let's try to compile and run it. Hope you like my video. I know I was taking things really slowly, but considering this question was difficult for me too, right? Let us consider some typing errors. Let's try to compile and run it. In the meantime, if you are new here, please do not forget to subscribe to my channel. Oh, it will be small n. because capital N was not defined as our input. Let's try it now. Hope it works. Oh, again an error. What is the error now? Oh, it will be here, right? So let's try to combine on it now. Oh, again an error is length equals to dp. This will be length. Sorry guys for so many errors. Yeah, correct. So it is running fine for combiner now. Let's try it for submit also. In the meantime, I'll request you to subscribe to my channel. You are showing an overwhelming response from last 2 to 3 days, and I'm liking it. So please continue that. So you can see 83 days current streak would not have been possible if it was not your love. So thank you for watching, and we'll meet tomorrow with a new question and a new energy. Till then, keep practicing, keep coding. Thank you. Have a nice day.